Good afternoon. Welcome back to the channel. This video is not financial advice. I'm a financial advisor doing research, make your own decisions. Okay, guys, welcome back. So in this video, I'm going to be talking about why the self-writing internet and caffeine AI is the iPhone moment for the entire internet. I know other people have given their thoughts on this, but I'm just going to be giving it from my point of view. And I would not expect to see a lot of people understanding the comparison here. And there's a good reason for that. Most people were very familiar. I'm going to call this the device stack or the old device stack. Most people were very familiar with all these devices. And so if we were to go back in time into early 2000 time period and say, hey, all these different devices are over time going to be combined into one device that you can also use for your phone, that wouldn't have been that hard of a thing for people to make sense of because they were familiar with these devices. They saw them all the time. They understood the basic functionality, and it just wouldn't have been that hard of a thing for them to conceptualize. However, comparing and contrasting to this situation, most people do not understand web architecture. Most people have no idea about how the web is designed. We're talking about a very, very small percentage of the population. There's tons of people that work in tech that don't understand web architecture. So most people don't understand the issue, don't understand all the problems with the current web, and tons of education would be needed just to bring people up to speed so they even can make sense of this comparison. Now, in this video, I want you to look at the old device stack, comparing and contrasting as being similar to a current Web 2 application, where you have a bunch of different systems all doing some type of function, but it's serving some greater purpose. Back 20 plus years ago, the purpose it was serving was just individual productivity, right? Using these devices as opposed to other means was just a more efficient way to get your day-to-day stuff done, right? So whereas on Web 2 right now, you have 6, 7 different systems all intertwined together, all serving their individual function to serve some overall purpose, keeping the application itself running. Okay. Now I would call this the iPhone moment times 1,000, a million, some hard to even, it's almost impossible to quantify because if you look at the impact this had, this improved individual productivity and efficiency because we're no longer using 6 or 7 different devices to get our day-to-day stuff done. We have it all in one device. So overwhelmingly improved efficiency. But that's on the individual basis. This is fixing all the problems on the web, fixing the problems with web development, fixing the problems with AI, fixing cybercrime, fixing the world's biggest problem. There is no bigger initiative that you could take on than fix the web. It's the medium the entire world uses to interact with each other. That's why I say this is the iPhone moment times some number that it's hard to even quantify. So right now, many different types of software systems are necessary for one working application. This becomes increasingly more inefficient relative to a better model, but it's all relative. If there's no ICP, then Web 2 is the best option out there, right? But as soon as there's a new model that improves on the old model, then there's your source of comparison. Then the comparison, as soon as there's a new model, the comparison becomes the most important thing. The iPhone 8 physical devices that we used, it ate all these different devices, right? ICP will eat layers of the software stack that are no longer needed and only create complexity, security issues, and sustainability issues. So that's what ICP and the self-writing internet is going to be eating. It's going to be eating all of this complexity and all of these different obsolete systems. However, most people don't even know these are there, right? And even if people did know they were there, they don't understand all the nuanced problems that come along with this at scale. So in this video, there are a lot of different ways where ICP solves for Web 2 architecture. I'm going to be narrowly focusing on a couple different ones in this video, but there are more and more differentiators. This is just a very big, broad topic because it involves all of Web 2 architecture. So in this video, we're going to be going over, because Dominic mentioned this not too long ago when he was giving his presentation, just talking about orthogonal persistence, talking about how application code, application data sticks together. That's why I want to go back into this now. I went over this probably 4 or 5 months ago, but given Caffeine AI is coming out, I do want to go back into this now. Okay. So we're going to be going over application code and application data being separate on Web 2 and the problems that this creates with AI and especially self-writing applications and how ICP solves for this. And then number two, overall complexity on Web 2 applications on top of the application code and application data being separate. There are more differentiators than this. I'm just breaking this up into different pieces. And so the desired functionality, this entire conversation is about the very specific functionality that I'm about to describe. The ability to continually update, change, and modify the application based on the end user's commands without, most important part, losing data or needing to stop for manual intervention. That is the desired functionality. And the problem with this on Web 2 is because you have all these different types of systems, more times than not, a lot of changes are going to require changes to the database. A lot of changes are going to require manual intervention. And there's nothing that you can just slap on top of this to get rid of this issue. This is an embedded issue in web architecture. So on Web 2, just picture you're using Lovable, you're using one of these other Replit, and it builds you an application. But the building of the application is one thing. We're talking about a different type of functionality. We're talking about the ongoing prompting, updating, changing, modifying, so on and so forth, without losing data or needing manual intervention. That's the specific type of functionality we're talking about. Now, when you're talking about Web 2, the issue here is that on a Web 2 application builder, because of web architecture, because application code and application data are separate, if you make certain changes to the application, you very well may need manual intervention to go back and reconfigure the database so everything stays configured properly. Everything, all of these different systems all have to stay configured properly at all times, or you could have performance issues or your app could just shut down. And so on ICP, there's no problems. On ICP, because they solve for these issues and everything is in canisters, these problems are solved. Okay, so you can just continually update, change, modify your application based on the end user's commands. Pause. When Caffeine AI comes out, I would expect limited and simplistic functionality in the early days. However, I would expect functionality to only grow over time. So after a year, it's going to have more functionality. 2 years, more functionality. It's just going to continually improve and be able to build more and more complex systems over time. All right. But the issue with continually updating and changing and modifying the application on ICP is not a problem because they have unified application code and application data and everything sticks together as opposed to having all of these different systems. Okay. Now, so how would this work on Web 2 when it comes to the application's already been built and now we're just changing, modifying, updating the application based on our commands? So how would this work on Web 2? Well, if the change being made to the application changes the nature of the application, I'll explain what I mean by that here in a second. Okay, which a decent percentage of changes will require manual intervention. Because if you want a lot changed on your application, if you want new functionality, if you want to change the nature of the application, well, unfortunately, you're going to have to make changes to the database and go back to make sure everything is configured the right way. The issue with that is that introduces manual intervention. So the core issue here is the application code and the application data are separate. So let's go through an example. And I used this example in my last video that I did about orthogonal persistence. But let's just say that you're asking the AI model to create you an application for tracking your custom workouts. Okay. So you say, build me an application just like you would with Caffeine AI on the self-writing internet. But this is a theoretical Web 2 solution. Create me an application for tracking my custom workouts. And then the very next day, you want to add meal tracking, calorie tracking, and to add something to track my sleep as well. The issue here is that you've changed the nature of the application. It was only set up with the database. This is a Web 2 example here. It was only set up with the database to track your custom workouts. And so if you need it to track other things, that has to be reflected in the database, which is separate from the application code. Application code, application data, separate. Creates a lot of problems and is going to create a lot of scenarios where it's going to require manual intervention. And so let's just general basics here, not going to get too technical or too in the weeds. But if we're just talking about a SQL database, it's designed to track, or it's designed to have, it's designed as tables, columns, rows. SQL database, tables, columns, rows. They're also called relational databases. But this is the other part of the software stack that normally has to be updated and reconfigured when you're making these different changes to your application. Okay? You're telling the AI, add meal tracking, add calorie tracking, add sleep tracking. That's what you're telling the application code to be changed to, right? Well, that has to be reflected in your database. The tables and columns and rows have to be reconfigured to track these additional things because now you've changed the nature of the application itself. The problem is this introduces manual intervention. And if you're thinking about this at scale, this is going to create a scenario where there's near infinite times where you need manual intervention from somebody. And so this issue alone creates a giant, so big I can't even explain, bottleneck when it comes to autonomously running applications. You just want a model to where people can continually change, update, modify their application day after day, week after week, to do their individual stuff and or to run their business without having to stop and call some software engineer to come reconfigure this entire thing so it's working properly. Web 2 applications are not structured to track things that are not, it's not a part of the application code, application data. All of this has to be configured properly. And there's more complexity beyond this. I'm just focusing on one aspect. Okay? So if you change the nature of the application, that needs to be reflected in your database. And this is not the only issue. There's still a host of other dependencies that could potentially cause problems. Everything needs to be mapped out and configured properly at all times. And a lot of times what happens is you have what's called data loss. Dom has also spoken about this. When you make certain changes and now all of a sudden you have data loss, you lose your data. But on ICP, everything sticks together. So this is not a problem. Updates and changes oftentimes require manual intervention. And on top of this issue, and this is an issue across the board for all AI services on the web, all Web 2 applications, this is an architectural issue with the entire web. Application code, application data being separate. And you still have all the other issues of Web 2. You don't own your own data. You have a $10 trillion cybercrime problem, and there's no transparency into what AI is tracking, recording, anything. And so the core technical solution here is called orthogonal persistence. And so you're really solving for autonomous AI-powered applications running at scale with the least amount of human intervention possible. It's not human intervention is, we're shooting for, the goal is autonomously running AI applications where we're just prompting everything and AI is doing everything else, where it's just a seamless interaction with you and your AI model, right? Not you and your AI model, and then every other day you're having to call some random software developer or engineer to reconfigure everything because of all the complexity. No. Yeah. So application code and application data stick together. And because this is not how the web-based applications currently work, a lot of manual intervention is needed. That's why the applications are so clunky and so fragile. Yeah. And so this was the example from Terry. Make these changes to the user interface. This could be like the same example of add calories, add sleep, add these other things as well, right? And so you can just continually manage, update, modify, customize the application based on your requests because this problem is solved for. Because the problem is solved for. If this problem wasn't solved for, you wouldn't be able to do this. As opposed to prompting AI, you would need to call some developer or software engineer to reconfigure everything the way that you want it. But they've collapsed everything down, going back to the iPhone example, right? Now we're going all the way back to the iPhone example at the very beginning. because what ICP and what the self-writing internet is doing is collapsing the entire software stack down into one full stack solution. And so when Dom's talking about data loss and when Dom's talking about continually changing, modifying, updating the application, and why this is such a big deal on ICP and why orthogonal persistence is such a huge innovation and breakthrough, that's what he's talking about. On Web 2, there's going to be near infinite scenarios where you're having to stop and you need manual intervention because of Web 2 architecture. And there is no easy fix for this anywhere. And what I just went over with application code and application data being separate is just one of many issues on Web 2. And so by combining everything down into one full stack solution and eliminating this complexity and this architectural issue, you eliminate the need, the near infinite need for manual intervention when you're trying to have autonomous running application. When you're trying to make changes to the application code, you're not going to need tons and tons and tons of different scenarios where you have to call a software engineer or a developer or some technical person to reconfigure everything the right way, because everything sticks together to begin with, because you solve the architectural problems. And so you can think about why this is important on an individual basis, whether or not you actually have the ability to just continually update with AI, or whether you have to start needing to call somebody else to reconfigure your application, call another human being to reconfigure your application. You can think about as an individual why this is a big deal. Now extrapolate out with hundreds of millions and billions of people all needing to pause and needing manual intervention every time they want to change something with their application. That's what it would be like on Web 2. But on ICP, you can just continue going because application code, application data, all of it sticks together and you own it. On a network where you don't have all of these other systems tied into it, you don't have all this counterparty risk, you don't have all this security and data loss risk. Guys, that's all I have for this video. I could keep going, but I'm going to go ahead and shut it down right there. I just wanted to dive a little bit deeper into this to go over the solution here and the concept of data loss on Web 2, why this is such a big problem, why this is going to create so many bottlenecks when it comes to AI-powered applications on the web, and why, in my opinion, ICP is inevitable, because this is just one of many problems that they solved for. And there's many other problems on top of this when you get into the rest of the Web 2 stack and all the complexity and issues that this causes. That's all I have for this video. Thank you, everyone, for tuning in today. This was not financial advice. Let me know if you have any questions. That's it. Take care. Have a good day. I'll see you in the next video.